Hello there, and welcome to another episode on our series on circuit simulation with LTSpice. In this video, I want to show you one directive called initial conditions, which you can use to affect how the simulation is supposed to happen. And what it does, just as the name suggests, is to allow you to set the initial conditions of some of the components so that you get to observe what you expect to observe. Before I show you that, on the screen right now you can see a very simple circuit. There is a 10k resistor connected in series with a 100 microfarad capacitor. And by the way, if you want to type microfarad, you don't have this on your keyboard, so you just do U, and because LTSpice already knows this is a capacitor, you can omit the farad, but I am pedantic and so I like to be very explicit when it comes to these things. So you type 100 UF and that is what assigns 100 microfarad to the capacitor. Now, based on general knowledge in electronics, you know that because the capacitor is connected across the voltage through this current limiting resistor, the rate at which the capacitor charges, or the rate at which this voltage V cap here builds up across the capacitor, is going to be dependent on what is known as the RC time constant, which simply mathematically is the value of the resistance times the value of the capacitance. So if my math is correct, if we have 1000k multiplied by 100 microfarad, 3 zeros will cancel out, and so we have 1000 microseconds, which is equal to 1 second. So what we expect to observe is that when we probe across this capacitor, like we've done, I've extended a wire here and I've put a net label here so I can probe here. We expect, based on your knowledge in physics and also in electronics, you expect that the voltage is going to rise slowly from 0 volt to 5 volt within 5 RC time constant. So if the RC time constant is 1 second, you expect that the capacitor is going to charge as close as possible to 5 volt within 5 seconds. Now, it will be surprising to you that this is not what we are going to observe. Before we simulate, I want us to set our transient analysis conditions. And previously, I told you the time you put here doesn't really matter. Of course, it depends on the circuit, right? I mentioned that if your circuit doesn't have any component that react based on time, then most of the time it doesn't matter how long you simulate. But in this particular case, it matters. If you set the time too early, then you don't get to observe what you want to see, right? So we know that it's going to take 1 second. The RC time constant is 1 second, and it takes 5 RC time constant for the capacitor to fully charge up. So if our RC time constant for this circuit is 1 second, we multiply 1 second by 5, and that should be 5 seconds. So we need to simulate this circuit for at least 5 seconds, but I'm going to make it 10 seconds just so we also get to observe what happens after the 5th second. So you put your transient analysis directive on the circuit and you simulate it. Now comes the moment of truth. I'm going to probe across here, and surprise, you can see that the voltage across the capacitor jumped from 0 to 5 volt right after the 0th second, and this is not true. The reason why this is happening is because we haven't set initial conditions, and the way we set initial conditions is to use a directive called .ic. So I'm going to click on this .t here, which is how you do directives, and then you say .ic. So the .ic stands for initial conditions, and I want to set the initial condition of the voltage across V cap is equal to 0. Look at it again. So the net label I added at this point is called V cap. And I want to tell the simulation that while it is starting, it should assume that the voltage across this capacitor is 0. So the way you do that is .ic V. The V here stands for voltage, and then you bring your bracket and then the name of that particular point where you want to set to 0. So .IC initial conditions voltage at V cap is equal to 0. Now you have to place it again. It doesn't matter where you put it, but I usually like to organize these things as close as possible to the element that actually utilizes those directives. So now I go to simulate here, and when I click on this, now you can see that we are observing what we expected to see. So because the initial condition has been set that the voltage across this capacitor is 0 volt, then what you actually expect, having read your textbooks on RC time constant, is what you will get to see here. So you get to see that the voltage is rising exponentially from 0 volt to as close as possible to 5 volt. And this, ladies and gentlemen, is how you use initial conditions to affect some of these things within your circuit simulation. Thank you very much for watching this, and I will see you in the next video.